Hey guys, this is Mohit Kukkar. I work as a data scientist with Gojek, mainly on the NLP side. Right now, I'm working with Indonesia Bahasa language to get the exact key phrases which we as folks generally give in reviews. Uh, Maybe some other time or some other platform when we connect, I can talk about it. But yeah, that's me. I'm also teaching masterclass with Scale Academy. Recently, I started this, and welcome to this class, or maybe session might be the right word. Okay, let's get started. Topic for the today's session is like predictive analytic fundamentals using linear regression. Now, these are very heavy jargons, right? Predictive analytics, linear regression, right? Before we talk about them, why not take a few minutes to understand what is analytics? Now, I know there's a very detailed and thorough definition on Google, which you can definitely find just in a minute. So let's not try go over there. Let's try to understand the essence of it, right? Now, there is a very weird phenomena happens with me every end of the month, and the weird phenomena is called "Where did all my salary go?" Right? I don't know how many of it happens with you or guys or something like that. But for me, it's always like, okay, it's 25th, 26th, and I don't know where my salary is, and how should I spend like next 5 days? It's always a problem, right? And that's where the idea comes. Okay, let me look at my bank statement and generalize my expenses. So this is generally a case scenario, right? Where like, okay, my salary is 50K, I have some around like 12K rent and 1K electric bill and following all the expenses, right? And you can see that, okay, I spend around 30K, right, out of my salary. Now, still, where is that like rest of the 20K, right? I should have that 20K, right? But before talking about that, where it went happen, right? All this summarizing of my expenses, right, is called descriptive analytics. Now, I know just summarizing my all my expenses is something like a fancy term like descriptive analytics. Now, English as a language has word for everything, right? So, yeah, this is called descriptive analytics. Now, don't get me wrong, this is just not descriptive analytics, right? Descriptive analytics is not just this. You can create visualization of your expenses, right? Your rent, electric bill in a bar chart or maybe a pie chart, right? Which is way more easy to understand or better to kind of utilize, right? And now there are companies who have actually like taken it to a full notch up and created dashboard, something like this, right? Believe me, in my very first year of my job, like I used to create these dashboards to understand our business, how things happens, so that they can monitor things, right? What's going on right now, right? So that you need to have that kind of pulse check on your business so that you can take decisions really fast, right? Now, in nutshell, basically, descriptive analytics is to understand what is happening right now, right? But the question still remains, right? As I said, right, the issue is still there that where is that less 20K left, right? Where is that money gone, right? Now, as I can see that, right, that, okay, 50K salary, rent, electric bill, there's a current balance. Okay, it's not 20K, I have 2K balance left, right? Now it is just 18K and all that, right? Now, if I have to see that, where is that, right? Okay, I go to the bank statement, go for more because this is general expenses which I remember, right? So I'll go to the bank statement again. Now I realize, okay, my general expenses is 30K, but I had one dinner with my friend, which was costed me around 2K, and that party, damn good party, damn good weekend, right? But it costed me pretty heavily, right? 7K around. And there was that bike repairing. Damn, my bike got kind of broke down while I was traveling from Whitefield to Koramangala back in Bangalore. And kind of, right? And it cost me 9K, right? This is the reason, right, why my kind of salary went away, right? You kind of forget these things, and you generally realize, okay, damn, this took my entire salary out, like good chunk of it, right? Now I'm like kind of left with just me 2K, right? Now to find all of these things, right, kind of understanding what's happening right now and what happened with my salary account is something called diagnostic analytics. You not only do a pulse check on what's happening right now, but try to find reasons behind things, right? And there is another fancy word for it, diagnostic analytics. It's pretty important for industry also, right? Let's suppose when I was working in Grofers, we used to get average orders around 1 lakh per day, right? Suddenly there is a day when order went down to 75%, right? Now, it's good that we have descriptive analytics so that we can alert our PMs, our higher management better. It's our also job to tell them why it happened so that they can pinpoint and take decision on that. So yeah, this is called analytics. Now, I know we figured out why the salary is missing, right? But we can't really be in this manner throughout the month, right? 2K at 25th, not really great situation to win, right? Now, if you look at my expenses again, right, I spend a good amount on Fortnite. Believe me, I'm a great fan of the game. I used to play a lot, and recently I have started spending, right? Now, it would have been good if I would have been earning a lot, right? But I think I'm not earning that much to spend 7.5K on Fortnite. So I should reduce this, right? And should put in some savings also, right? Fathers always say, save, start saving early, right? So yeah, now if I have to keep myself in a situation where I'm not living with 2K, right? I know bike maintenance is just a one-time thought, right? Or one-time exercise, right? But I should start spending less on Fortnite to have be in the situation where I can save money, right? That's another fancy term. Prescriptive analytics, where we basically tell them solution, right? So we found what's happening right now. We found the reason behind it, and we are giving a solution for that, right? To the company or to ourselves, right here. That okay, start spending less on Fortnite, and you will be in a better situation at the end of the month, right? Now I know, the title was okay, predictive analytics, right? We have talked about each and everything except predictive analytics, right? Now, what is predictive analytics? Why are we not talking about it, right? Now, let's take a look at grocery, right? I'm paying bill of 4K for grocery. Now, uh, I know I'm a really bad planner for grocery. Never been that good. I always go to my cook and he says, but do you know our moms are a very good planner for grocery? Have you seen them planning at the start of the month? They have a long list. They are always writing, okay, dal this much, rice this much, atta this much. They have the long list. And somehow their entire planning goes throughout the month, right? Like at 30th, they have still so much left, and that much that it will only go to 2 or 3, which is extra budget Russian, right? Nothing more, nothing less. How are they always perfect, right? They kind of do okay, how better than us, right? So I feel like my mother always have that kind of insight. Okay, in the last 6 months, she knows how much rice has been consumed per month, or kind of that, or dal has been consumed. Okay, my relatives came in but one particular month, or are going to be there, so they need extra and all that, right? She have all that insight, right? If I have to be very specific or very simple in saying, right, she has the past data, right? She knows when how much have been consumed, right? She have done experiments also, right? She ordered, let's suppose, 5 kg of rice one day, and that month it was extra. The next month she might have just three, right? And that might have lead to consumption early, right? Now she has all that past data, experiments, and all that. That's how she knows that okay, if I give order of 4 kg, that would be perfect, right? Now this is a pretty good example of how predictive analytics is used in our day-to-day general life, right? But grocery planning is a way more complex structure, right? There are a lot of things, seasonality and all that, and there can be a lot of things, right? But to understand that, let's take a very simple example. But before that, let me just check the questions if you guys have any questions or something like that. But can diagnostic analysis can use to prevent the expenses? Yes. So basically, the reason we are doing right the analysis is basically the reason we are doing diagnostic analysis to find the reason behind it. If we are already aware of the reasons why a certain thing happens, right, we can be cautious about things so that it doesn't happen. I hope that answers your question. So again, as I said, right, we have talked about all of these things, right? Diagnostic, descriptive, prescriptive, but we haven't talked about predictive, right? I talked about basically, uh, how would I say, how grocery planning does, right? That's an example of how day-to-day life predictive analytics is used, right? But that also has its constraints and all that. I wanted to show you, or let's discuss how it is done in a very simple manner, right? So yeah, let's go to example of height and weight. Very age-old example, right? Back in the 9th and 10th, if you remember, there'll always be, okay, we have 100 people, height of varying from 150 to 180, and what would be the average of it, right? What would be kind of median of it? So yeah, let's take with a very simple example as like that, right? Let's start with that. Now, there will be a lot of basically, how would I say, request here that I should take an industry example, but do you believe me? We'll connect to that. So be patient with me here. And let's start with people who are not really aware about how general predictive analytics and linear regression works, right? So let's come back to example, right? Height and weight, right? Now you can see we have certain data for height and weight. There's like 155 centimeter, 48 kg, then 179, 171, and all that, right? Now at the end, I've left a particular data blank for weight, right? I have height for 177, right? Can you please, guys, just give me suggestions? What will be the weight for 177 centimeter? I would really love that. Okay, 70, 52, 70, 70, 70, 70. Okay, 67, 67, 70, 70, 65, 66, 70, 68, 69. Okay. Uh, it seems like a lot of people are you saying that it will be around 70 kg, right? So for now, let's keep it at 70 kg. And I can see that a lot of there could take average of weight, okay? And there is a lot of suggestions around 70. There are other things also. So for the sake of majority, let me write kind of 70 kg for weight, right? Okay, let's go ahead with that. Now, if I have to visualize this data, right? If I have to visualize what's happening with our height and weight, won't our data would something look like this? I have kind of like dotted all these kind of what would be our data table, right? Now, I know you guys have said that there will be certain answer for 177. So let's suppose this is the point for 177, right? Now, can you tell me what would be the answer 70 kg would be out of all these three? Can you just give an answer? Out of all these 3 points, what do you think our answer would be? Which you generally were saying 70 kg. First, middle one, middle not, center one, middle value. Okay. I think we have kind of majority on the middle one, I guess. So this is the one I think you people are thinking that, okay, this is the middle one. Top one. Okay. Median. Okay. Okay. I think we have kind of a mix between top one and middle one, but the middle is still winning. So yeah, let's go with the middle one, right? But how do you think we came up to this? How do you think we came up to that particular prediction? Okay. Before like we say about like, okay, this is the right prediction and go into all those fancy terms, right? My question is the same that how did we come up to this prediction? Do you think we can say something like, okay, this data can have a basically trend line, right? Which can be looking something like this. Can we say this kind of? And that's how you said, okay, that this particular value, right, which is 177, kind of came up to be 70 kg, right? I know a lot of you were saying earlier, okay, we will have a line y equal to x or something like that, linear regression, right, and all that, right? But in a simple manner, right, whatever data we said, 177 centimeter, we said, okay, we will have a weight something, right? And you guys were said 70, and you took a middle value, right? But how did we come up with that? Do you agree that we think intuitively that there's some kind of trend line which this data is following, and based on that we have said that, right? I plotted that kind of line, right? I think you will agree, right? You have 10 lines in graph sheets, regression line. Okay. 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 So yeah, the idea was behind that, like the way we are choosing this, right, is kind of looking at the trend line, right? But my question to you guys is, how do you know that this is the best line out there, right? How do you know this is the line, right? Why not this one? Or why not this one? Or even why not this one, this magical multicolored line, right? I know it seems very, very stupid to say that this might be line, but how do you think that which is the best line, right? How do you come up with that? Now I know by looking at the data, it just feels like a general intuition that the original line seems like a better one, right? Or maybe even the red one seems right? But when we look from a scale point of view, right, we have somewhat 15 data points. But when we look at a data point where we have 20 lakh rows or 50 lakh rows or go even lower, right? 10 million orders per day. Think of Flipkart or like Amazon scale, right? If we have to do some kind of saying that, okay, for that particular order or something, we have to say, okay, we want to find this particular value, right? We can't just go with intuition, right? We can't really go with that. We need some kind of way to say that what is the best line to fit, right? Now, how do we come up with that particular line, right? So let's start with our most stupid line, right? The most colorful stupid line, right? The reason I'm starting with it seems like a very, I would say, good reference point. It's pretty easy. It's a parallel line to our x-axis. We can do some analysis with that, right? Now, if I have to say that, as I said, right, if I have to scale things up for a very large amount of data or something, and I have to say this is the best line, right? How would we find the best line? Now, if I have to find the best line, uh, I would say it fits well, right? It should fit well. It should predict most of the things better, right? Because at the end of the day, in this particular example, we are going, okay, I have the height, I need to find the weight. That's a prediction, right? So, how would I have a line which fits all the data points pretty good, right? It has the best prediction, right? Can I say that for each and every point like this is the kind of error, right? Or this is the error, this is the error, this is the error, kind of, or even this is the error, right? So, yeah, can we say these are the errors, right? Okay, if this is the error, how would we write it, right? So, let's say this is a line equal to y equal to b. I know it can be weight equal to b basically, right? Because there is no x influence there. It's parallel to it, right? If it's equal to y equal to b, right, I can say this particular point, the very first point, right, y equal to y1, right? Thus, the error could be b minus y1, right? Then for the second one, it's basically y2, right? I can say the error is b minus y2. And similarly, for the third point, it's y3. I can go b minus y3, right? But there are a lot of errors, right? I can keep on writing it till we have somewhat like what b minus yn, right? Do you think our error would look like this? Something like this beautiful equation, I would say, right? But I do have one concern with this, right? Now, if you see for the very first point, right, uh, b, b minus y1 is a positive term because b is higher than y1, right? But for the second term, right, y2 is a greater term than b, right? It will be negative, right? This is negative, this is positive, then this is again positive. If I look at the last one and consider that n, right, that is also negative, right? Now, if I calculate the entire term, if I sum it up, right, the entire error term for us, right, the error will cancel each other out, right? I don't think we want that. We want to find the total error, right, for each and every point so that we can have the best fit, right? We want to reduce this error a lot, right? So to do that, to make things positive, right? I don't want the negative terms, right? Why not just square the terms, right? Square is always positive, right? Do you think the equation will look like this, which will be better one? Because each and every term is a positive one. Even the negative one becomes the positive, right? And I can do the total of all of that. Now, jargon alert here. These all things, right? We have a term called residual, right? Residual generally means that, okay, whatever got left, right? Do you think these things got left from a line? When I was trying to fit a line, these errors were left. So we generally say this particular entire big equations are called sum of squared residuals, right? At the end of the day, we have these residuals which we are squaring for the term so that the sum is always positive. We are not canceling each other out, right? And it's a sum. So sum of squared residuals, SSR. Till now, any questions, any doubts? I'll look at the question board right now. Why not mode? Yeah, great question. I'll answer that in a minute. Okay, we can definitely take absolute value, something like this, right? B minus y1 plus b minus y2 absolute plus b minus y3. But do you know why it is not really accepted at overall level? Because when you go in a general maths operation, right, when you're trying to take a derivative of it, or when you're trying to take an integration of it, right, is the most tricky for mod or absolute value, right? Or when you're taking a differentiation, right, if it's a simple term, right, most of your b will just differentiate to zero because it's just a single variable, right? And you will not get anything, right? So another benefit of taking a square basically is to make maths easier, right, at the end of the day. So yeah, I hope this particular answers the why not absolute thing, right? Because maths become very, very tricky. You can't really differentiate stuff because you will get simple constant value. You can't really integrate stuff here because it becomes kind of that. Is SSR same as RMSC? Not really. RMSC is something like root mean square error, right? Which I will cover ahead. But if you have to take a root overall of it, right? And let's talk about it later, right? So yeah, let's go ahead. I think I've answered a few of the questions here. Let's go ahead and look at what's there. So yeah, as you said, right, that we looked at a basically what horizontal line, right? But our line was not a horizontal line, right? R was a this slopey line kind of thing, right? What will be the error here, right? Can I say this that in this case, my line equation is equal to y equal to x plus b, right? Before jumping into it, right? Can you guys help me? What is the actual equation of a line? What's the general way that we say, okay, they represent a line in maths? Okay, I think I see a lot of common answer equal to y equal to mx plus c. Exactly right, y equal to mx plus c. But somehow, for some reason, I don't know why our ancestors were like very much obsessed with p, q, r, m, and all that. I'm not, so I'll just use m a x plus b, and that's where I'm going ahead with y equal to x plus b. Similar thing, right? Now this is a line equation, right? If this is a line equation, the way we have done in the past for basically y equal to b, right? Can I say that my error function or the sum of squared residuals, right, can be written in this manner? ax1 plus b minus y1 square, ax2 plus b minus y2 square, and all that. I think I missed y1 kind of. My bad. But yeah, it's ax1 plus b minus y1 square and continue, right? So this is a way to write a general error, right? We looked at kind of a horizontal line and what would the error in that. If I look at any line with any slope a and any constant b, this will be my kind of total error, right? So yeah, this is known as sum of squared residuals as I talked about, right? Again, jargon alert here. Sum of squared residuals is also called cost function. I know there is a very famous professor, Andrew Ng, and most of you might have or would in the future would listen to his lectures, right? He used the like function term called cost function. This is another way of calling sum of squared residuals. So yeah, this is also called cost function. Now, I know that we are still answering the question, right? That how do we know this particular line is the best? I know we talked about error term, right? We have this long, somewhat weird looking line of error, right? But how is it useful, right? Okay, let's look at how is it useful, right? Now, I have like basically simple graph available, right? Where I have like I'm trying to plot sum of squared residuals, right? What am I plotting with, right? I have different, I would say, rotation of line, right? We looked at a horizontal one, we looked at a particular slopey one. So let's try to plot it, right? Now, when I look at a horizontal one, this is the value I get for sum of squared residuals. Let's try to rotate it a bit. Okay. Sum of squared residuals reduced with somewhat of a basically rotation. Let's try to look further. It reduced further. Wow. Let's try to okay, it kind of increased, right? I'm trying to increase the slope, but earlier it was decreasing, right? But again, increased. Okay, let's try again. Damn. I even changed the slope kind of way we have slope, but our sum of squared residuals is increased, right? But you see a total kind of a way that we have right now, right? This entire graph kind of looks like a parabolish, right? That we have some kind of a parabola, right? So do you remember back from school, right? We have parabola and entire equations, right? But one thing which we always remember, right, is to find minimum value of it, right? Can I say this is the minimum value of this particular graph, right? And if you recall, what we are trying to do is to find the minimum value of error, right? Because I think that's the best line we have, right? A line which fits the data pretty well, that reduces the error as much as possible, right? That's what we're trying to do, right? So at the end of the day, right, what we are trying to find is the minimum of this function, right? Now, whatever be the number of values, right, whatever be the number of records, be it for Amazon, like 10 million orders per day, or be it for Grofers, which is 1 lakh orders per day, right? It doesn't really matter. At the end of the day, we are just solving equation and we are trying to find the minimum of it, right? Now, okay, let's see if I have to look at the minimum value of it, right? Oh, best relation equal to minimum of sum of squared residuals, right? Now, okay, I'm already calling out something, but it's not supposed to be. But yeah, if I have to find the minimum of a function, right? Do you remember that we used to do differentiation back in school? Back in ninth, there was, okay, I have a parabola function, I have to find the minimum of it. And if I have to find the minimum, I will basically find this point where the slope is zero, right? How do we find the slope? We just take a differentiation of it, right? Now, I have just written that. I know for some of the folks, suddenly it turned from a very simple line of thought and we were looking graphs to certain maths. Don't worry. The idea is basically a simple differentiation, right? And the entire idea of this session is basically how linear regression, any of the predictive analysis, is basically simple high school maths, right? Nothing more than that. So do ask me questions if you're confused or overwhelmed. And some people who are like already way ahead, be wait patient for me. I'll come there. But one thing which is here, right? One problem with which is here, right, is that we don't really use D for a partial differentiation. I know I'm getting way more fancy in the terms, right? But our equation, right, which is y equal to ax plus b, have two variables: a, which is slope; b, which is basically the constant, y equal to mx plus c, right? And I'm doing differentiation with both of them. When we do with the both of them, right, two variables on the up and down, right, we don't really write in a like complete differentiation. We generally write it in a manner of partial differentiation. I know this is the symbol change, right? Let's keep it that way, right? And if we equate zero, right, we get this kind of equation: y equal to 0.26x plus 29, right? If I put that value 177, right, this is the answer we get. Weirdly, this doesn't match with anyone's of intuition, right? Our intuition was kind of 70, but we are getting kind of 75, right? That's the reason, right? The human brain, again, the human intuition has kind of limitation, right? And that's the need where the entire predictive analytics comes, right? When you go at a scale, right? When you go at a very high value of orders or very high level of transactions, right? You have to go to maths. You have to go to maths for scaling things, right? Till now, any confusion, any question, I'm coming back to the question board. Do let me know. Okay, let me try answering it a bit. Uh, so people who just said, right, like I never understood differentiation integration in 12th, right? I know it's been always overwhelming, right? All those integration signs, all those differentiation lines and all that, right? But that's the very basic of it, right? I know it's been overwhelming, but do take another look. You can get it, right? We were young back then. Maybe now you can understand pretty quickly, right? It's not that tough. Believe me, you have gone through colleges or are in the college, right? The maths have become even more tougher, right? It's always good to revise that. But believe me, it's not that overwhelming. So do give it a try, right? I'll answer the what is the significant of intercept, meaning can we use two data sets and convert into y equal to x plus b? Yes, Ritvik, you can definitely basically convert any two data sets and like try to fit a line here, right? Because when you go into industry problems and all that, you might have a lot of features and you always try to look at basically any two. So you can, but there is a definitely caveat with that, which I'll try to explain at the very last. So be patient with me there. Okay, I think a lot of people have asked to try to explain it again, and I will. Okay, let's go back. Okay, I think till the point here, the equation came in, right? It was pretty clear, or was there any kind of doubt there? Shall we start again from here? Okay, I think it's pretty clear from here, right? So, yeah, let's start from here, right? Till this point, what we kind of found was basically that we have data points, right? We want to find a particular data points value for weight, right? We have a height value which is 177, right? Which we wanted to predict for weight, right? Most of you guessed that 70 kg would be the weight for a person with 177 centimeter height back on the data we had, right? Now, when we're looking at that, right, we said, okay, if we look through a particular lines, right, if I go back to the slides, if I go back to this particular point, we said, okay, that we want to particularly visualize this particular point, right? And we said, okay, this 177 looks something like 70 of this, right? But how did we came up at this point? Because before this, right, I asked for what out of all these 3 points kind of looked like, right? And you guys generally from a majority point of view took the middle point. So my question came in, how did this point actually came up to you from intuition point of view, right? Now, from intuition point of view, when like we said, okay, this particular data looks like that it follows a particular linear trend, right? And we try to make it visualize, right? That's when we draw a particular line. Now, someone asks, what is the basically significance of basically the intercept, right? Now, what would I do something like that if I draw something like this? Does this look like that uh, it's particularly like following the data or following the trend line, or does this look like following the trend line? It doesn't, right? It doesn't, because it should like kind of try to fit the data, right? I understand that it feels like, okay, the slope is the reason for the rotation, right? But think of a point where we say that, okay, a person with a height or weight, right? If a person only has something like a 120 height or something, right? It doesn't mean the weight will become zero, because we have a data set from 130 to 140, right? There will be a minimum value for weight also, right? That every person will kind of achieve on a general level, right? That minimum value of weight, right, here, or like opposite, right, kind of, is something which is coming from intercept. That's why intercept is pretty significant for us. Now, coming back, uh, if I look at this linear relation, right, the next question was, how do we interpret that this linear relation is the best one, right? We said, okay, this might be the best one, or this might be the best one, right? And my next question, which was way more stupid, right, was this: can this be the best one, right? This colorful one, kind of, right? It doesn't, right? It doesn't look like that. But how did we come up with this, right? It was more at looking at a graph or something like intuition, right? So basically, from an intuition point of view, right, it's good that we can come up with limited data points, right? But when it comes to higher order values, right, I took example of Amazon, Flipkart, where the daily orders are around like 10 lakhs, right? Or for Grofers, which was like around 1 lakh, right? You can't really generalize that from a graph point of view. You can't really visualize that. You can't really basically do a mental maths for that, right? You have to go into the paper and pen and you have to write the maths for it, right? Now, I know it seems a bit overwhelming. Okay, suddenly maths came in, right? But it's not that kind of tough, right? For reference, right, I said, okay, we have a horizontal line and we have all these data points, right? Now, to have a line which is the best fit, right? When I say best fit, right, it means that it is trying to like predict the best value for each and every weight, right? When I go back, there are 4 lines, right? If I take the very first line, the dotted line, it seems like when I take that and put some value, it will be have the closest to the actual value, right? That's what we're trying to do. When we have a horizontal line for reference, right, we see that, okay, for each and every data point, we have some kind of difference, right, between what this line would say that if I take particular this point, right, or like let's suppose this point, my particular line says that equal to y equal to b, right? But the weight is something equal to y, what is n, right? So there is a difference, right? That difference is something like yn minus y equal to b, right? Similarly, for each and every other point also. Now, this is what we're trying to write in a, how would I say, a proper mathematical manner on a paper pen, right? And that's what we tried to did, right? We said, okay, that for the very first point, where like for this point, right, that our like equation says that it should be b, right? But our particular exact value is y1. So the error is b minus y1. For second one, it was b minus y2 and b minus y3 and continue, right? But the problem with happens is in some cases b is greater than y1 and in some cases y is greater than b, right? It's always like positive negative game, right? It will always be kind of canceling each other out, right? To make sense of it, right? One way is to square the value so that each and every value is positive and adds up to it, right? That's where I said, okay, this is another way, right? That b minus y1 square plus b minus y2 square and keep on going on till the nth value, right? That we have a lot of all of errors, right? Now, there is one question for that was basically that why not mode, right? Why not take the absolute value? That's what we meant with the mod, right? The problem with absolute value, right? It seems right here, right? That if we take absolute value, it will add up all the basically errors, right? But the problem comes in that you can't really differentiate, integrate something. The maths become very, very tricky, right? Let's suppose if you have just b minus y, right? If you differentiate something, it will like b is a single variable which will differentiate it and easily, right? Equal to basically some one or something. The constant will become zero, right? You can't do anything with that. Just to make things easier, right? Just to make maths little tricky, we went ahead with a bit more complexity of squaring it, right? So yes, definitely you can do more, but when you go keep on going into the maths, right, things become way more tricky. To make things easier from a maths point of view, right, and to make it consistent, we generally take square, right? That's why we also call this term as sum of squared residuals, right? Because we are summing all the residuals. Residuals from a simple English point of view is basically whatever is left, right? Here, whatever the prediction is missing from the actual value, this residuals, and we are squaring each bit, right? Now, we have talked about a horizontal line, but generally a horizontal line is never there, right? We have to fit something with a slope, a general line, right? Where I talked about that, okay, y equal to mx plus c is a general equation, and how should we? Now, same thing, right? Sum of square residuals, if we have to write in a more general term for any line, right, which is y equal to x plus b, we wrote a sum of square residual like this, ax1 plus b minus y square plus ax2 plus b minus y2 square, right? This is the generalized way of writing what we did in the previous slide, right? B minus y1 square and all that, right? For each and every line, right? Now, whatever value we have for A, which is slope, and B for constant, right? We will get some kind of value for weight when we put some value for height, right? Okay, this is understandable. Can you relate this with the example? Okay, yeah. So the initial point, right, which you were doing was that we have a weight value, height value of 177 centimeter, right? And we wanted the weight value out of it, right? What we're trying to do is finding the best idea of that, right? To best the kind of the best value, right? We don't know how you came up with 70. That was more of intuition, right? We want to find the actual value, right? To do that, we said earlier, right, that the equation fits a line. We feel like the intuition is that there's general line fitting. We are trying to find the best line, right? And that is how we are doing this entire like maths, right? To find the best line. Now, as I said, right, that we want to find the best line, and we were trying to do okay, horizontal. This is the sum of square residuals. We rotated a bit more, and these are the values, right? We can see that there's a proper trend following that. There is a particularly uh, kind of a function out there, right? So we have to, like, if we want to reduce the kind of sum of squared residuals, right, then we have to kind of find the minimum of this function. I know suddenly the thing started from simple graph and line to suddenly a term called minima, right? What is on the horizontal axis here, right? This is just different rotation of lines, right? So it's pretty simple, right? That we have sum of squared residuals on the like vertical axis. On the horizontal axis, these are just different rotations, right? If it would have been the line we look at, right, was kind of horizontal line, right? The sum of squared residual value is that the very first one. If we rotate it a bit, right, now we have different values when we take from equation. That comes a bit lower when we looked at the data, right? If I rotate it a further bit, right, yes, y equal to x plus b. This is the equation, right? So basically, if we further rotated the sum of square residuals further, but when we further rotated further more, right, this particular thing changed, right? And even further got it, right? So this is what I'm trying to explain from this particular slide, that the more we rotate the line, different sum of square residual values will come, and we try to plot it. Now, when we looked at the plot, right, we see that, okay, the kind of graph is becoming what we used to learn in the school, right? Something like parabola, right? There is a minimum point, right? And that's what we are trying to do. To find the best line, to get that value 70, how did we come up with, right? To find the best line, which is representing all the data well fit, right? We are trying to find the line which is the least error, right? The minimum error. And to find minima of a particular function, right? We generally go to basically derivatives, right? And the idea is basically the last slide, right? For a particular minima, the slope of function is always zero, kind of, right? Now, to do that, right, I'm just doing a simple derivative, which is basically derivative of function equal to zero. I'll get a, which is slope equal to zero. If I do a slope equal to zero, basically, what if it decreases after that increase? Okay, I'll do that. I'll answer that also, right? But we are trying to equate to zero and find the values of a and b. Here, what I was trying to explain before that was that generally when we write derivative, right, we use d term, right? D of something, j or function like that, by d of theta or something like that, right? But the idea was that kind of that when we do, like when an equation has two terms in it or more than two terms, right, which you'll face in a lot of kind of values, right, you will kind of like you can't really use this terminology. This is just a maths thing, right? If you're doing with the two variable and kind of, we generally say it's a partial differentiation. That's why you use delta instead of d. How is it basically calculated, right? So if I do a differentiation of the entire equation, right, the ax1 plus b and all that, right, kind of going on. When you do a differentiation equal to zero, you get all those a terms, equate all of these x1, x2, and all those kind of things, because we have from graph and all that, and we have b also, right? Now we will get equation of a and b. If I do a differentiation from a b point of view, I have again will have a value of a x1 plus something like that. We have two equations which will solve it. That's how we get a and b value in here, right? But the problem with this entire thing, right, we already solved it, and this is how I came up with the equation, right? That y equal to 0.26x, and when we put that point 177, which started with the initial data, right? This is the value get it. The reason I'm showing you this is once you started here, right? Once you started the entire thing, your intuition was saying 70, right? That's what human do, right? We have a limitation of doing from intuition point of view, right? But when we actually like calculate it, right, it's 75. And that's what happens in actual industry also. You can't really go from a human intuition point of view, and you have to look into predictive. That was the idea of entire predictive analysis, right? That most of the time when we do some basic planning in the day-to-day life, right, grocery planning or what we are doing, kind of, that's basically predictive analysis, right? But when we have to look at a very huge point of view, humans generally go to, if you have to do a lot of calculation, you do like simple calculator, right? Now, if you have to do it for a different things, you go on a pen and paper and write that. At the end of the day, it's simple high school maths which you used to do, right? Back in the school. That's the entire agenda of this particular session. That it's not something like fancy or something like that. At the end of the day, it's simple high school maths, right? What we're trying to do, right? Now they're having a lot of questions on. There was a question on, okay, what if it decreases after increase, right? Let's suppose I'm drawing graph. This is the plot. Let's suppose. Now, this is the question. What if it increases after that and decreases further, something like that, right? Now, this is also the problem of local minimum, right? We can further go into the like particular all these kind of maths that like, okay, how we solve for local minima or how we solve for all of that. Different things that, okay, there's another call out from my end, like, okay, what if the function is tending to zero, right? I further also draw it, but what if it's never going zero? How would we find minima, right? We can't just go for zero, right? So these are all maths complexities, which we can like talk about share. But for this particular session, I'm like more focusing on the idea of how you can use just high school maths for predictive analytics and all that. So uh, as I said, one call out was what if the function is tending to zero, right? Now the idea is that I've shown you graph, right? You can't really use basically a derivative equal to zero, right? That and that's the idea of gradient descent, right? The entire gradient descent is coming, right? Now, the idea of gradient descent is what? Basically, let me explain, right? Let's suppose you can't take a zero, but let's suppose you take a random value. Maybe this is the random value, right? You start with that, right? Now, if I have to find the least value, right, or the best possible value, the least kind of, right? You keep on going further with some point. You check, okay, you went further, okay, it's still there. You come over at this point, you keep on going there and further there, slowly and slowly, very slowly and slowly, till you find a value which is pretty good or pretty decent, right? And that's what we generally do in these equations. We have kind of, let's suppose the idea, like I'm taking a simple parabolic functions to explain you easily instead of using that complex function, right? But the idea is you keep on going slowly from each boundary point. Let's suppose you come up with this random starting point and you go slowly a bit. You didn't find the least value. You go slowly a bit. Still, you didn't find the least function, right? You go again. No. Now you go here. Same. But next time you go, right, further for check, right, kind of, you realize that your value actually increased for sum of squared residuals, right, which you talked about, the error term, right? Now what to do, right? This is the problem, right? So what we do is basically we keep on, instead of taking these big steps, we don't just take smaller steps, right? Even smaller, right? Till the time we realize, okay, now it's increasing. That was the last point we should take. That's the basic intuition of gradient descent, right? You start with a random point instead of zero, because sometimes you can't find a zero, right? And you keep on going slowly till the point you see that, okay, that's the least, I would say the minimum point, right? And you can take that, right? Similarly, if you're going from here, right, is the same thing. You keep on going slowly. So it doesn't matter where you're starting from, right? The idea is that you can take any random. And the reason, the way we do it in basically the maths is basically we can say this, that we are looking for maybe slope, right? We have slope equal to A, then we are differentiating it, right? The cost function or the sum of squared residuals by A, right? Now this lambda or like alpha is generally said something like learning rate, right? The idea of this entire thing is how big these jumps should be. Should it be this big or should it be just this big, right? How small or large should it be? Because if we make very small, right, it will take a lot of time. If we make very big, like the way we did in the last here, right, it will suddenly jump from this particular side to this particular side, right? And we start suddenly going up above our sum of square residuals will keep on going up, right? So this is the role of this particular learning rate. And the idea is like you have slope minus you do some differentiation rate of change, multiply with some value. Again, you will get from this value to this value, right? Then this to this, then this to this, right? Slowly and slowly, you will come to the lowest point. So the idea I said, right, you can do any kind of random point is this, right? That if you start from this, right, and you go there, that particular number is negative, right? And this is also negative, right? So it will keep on adding to the A, right? It will keep on adding the A, right? Because we are increasing the slope of the line is further increasing, right? Because the slope, now this, slowly increasing. On the other side, for the other side, right? The differentiation part is always positive when you're reducing, right? Now that is negative. In that way, our slope is further reducing. This is why, like, this is how we can say that you can take any random value on any of the side, right? And we'll end up with the minimum point. That's the basic intuition of the gradient descent. Now, I know basically we have suddenly gone from simple graphs or simple prescriptive, descriptive analytics to differentiation and for suddenly something like gradient descent and all that, right? And it becomes somewhat complex for someone, right? So why not look at a actual real life linear relationship, right? Instead of going at a two example, right, which we look at height and weight, right? The idea was to explain how things work, right? So before going that, let me just look at it. Before that, we have Mudit here.
Hi everyone, my name is Mudit Goel and I lead the data science and machine learning track at SCALER. So wanted to share a few insights with you based on a survey that we had done with 100 companies. Now let me share a few insights with you from a survey that at SCALER we had conducted with 100 data scientists and machine learning engineers. Most of them belong to India, some in the US, some in Singapore. And all of them belong to the top companies or startups. Now, from that survey, it turned out that as a student, sometimes we feel that for freshers, especially, it's difficult to find a job in data science, machine learning, and the companies are only looking for people who have experience, and it's so difficult to find a job. There's not a lot of jobs available, etc. But when we spoke with companies, it turned out that the companies are telling us the opposite story. The companies told us that it is very difficult to find candidates in data science machine learning. We are trying to hire a data scientist for a while and we're not able to find them. Tell us that our machine learning engineer role has been open for past 8 months and we have not been able to fill that role. Okay, so that's very different, the complete opposite of what we hear from students. So where is that gap, right? So on one end, students and fresh grads, they think that it's difficult to find a job and not a lot of jobs are available. And on the other hand, companies are saying that we are not able to find people to fill these jobs. So we were trying to figure out that answer, and in our survey, it turned out that it's just a few skills that right now are missing in some of the online courses and even in the university degree programs that offer you data science and machine learning. And the one main big insight that we got from that survey was that although data science and machine learning are technical roles, and obviously you need to understand the algorithms, the models, the maths, everything that Mohit is covering today. But one more thing that the companies are looking for is your understanding of the business, because the problems that you're going to be solving are going to be business problems, right? The models that you create are only going to help you in solving a particular business problem, right? The reason why a company is hiring you is to improve their business, improve their products, help them in decision making, etc. The company is not really hiring you to just increase the accuracy of a certain model. Okay, so that's why understanding of the business is very important. Now, let me give you some examples. Let's say you're working at a food delivery company. As a data scientist or machine learning engineer, one of your projects could be that using the data, design a marketing campaign for us. Now, in this case, you can see how open-ended this business problem is. And you would need to understand how customers behave, how marketing is done, how to maybe get more signups, how to get maybe better conversion on your website, how to improve your revenue and profit, and so on. So you need to have that understanding as well. Another example is, let's say you're working at Uber, and one of your problem statements could be that using data, figure out whether Uber should launch a bus service in Bangalore, right? Now, this is not an easy question to answer, because if you, let's say, launch a bus service, it is possible that some of the people who were earlier taking the cab now start taking the bus, but the revenue that you get from the bus service is per traveler, per rider is significantly lower than the revenue that you get from the car. So the bus can actually cannibalize your cab business. And instead of making additional revenue, you might actually end up losing revenue, right? So these are the types of decisions that you would have to make as a data scientist or a machine learning engineer. So it's not enough just to have technical understanding. You also need to understand how the business works, the company strategy, the product development, how operations work, how logistics work, how sales works, how marketing works, how HR works, and so on. So the SCALER Data Science and Machine Learning program, we have designed it in a series of 80 business cases. Okay, and I'll show you some of these examples over here. You can maybe see my screen. Okay, so some of these examples you'll see on the website of the kind of projects that you're going to be working on. So these are actual business cases that we have built in partnership with some of the top companies. So we have in our partners a ride-sharing company, we have a food delivery company, we have an e-commerce company, and so on. So we have companies from various different industries. You're going to be working on 80 business cases. Each of these cases is a real problem statement that that one of these companies is currently working on. So as part of the course, you're going to be working on problems that real data scientists and ML engineers are right now working on in their own companies, in some of these top companies. Okay. As Shankar is asking, placement assistance is available. By the way, all of these partnerships that we have with these companies, the reason why these companies partner with us is because they want to hire our graduates. They have no other incentive. The reason why they give us their data that we share with you, the reason is because they want to hire the candidates. That's the only incentive that they get. So there are no financials involved in the partnership. The only give and take is that the companies give us their problem statement and a data set, and in return, we give them our students. Now, besides the business understanding, in the course, we're going to be covering the basic maths that's required. We're going to be covering data science, machine learning, and we will write all the algorithms from scratch. Then we have deep learning, in which we will cover computer vision, natural language processing, as well as reinforcement learning. And after that, we also have a module on data engineering and machine learning operations, in which you will see how to deploy models to AWS and Google Cloud Platform, as well as you will be learning how to deal with big data and distributed systems, right? So if you are dealing with a very huge amount of data, so then we'll teach you some tools, for example, Spark, Kafka, Airflow, and so on. We'll also teach you high-level design, low-level design, etc. Plus, also we'll teach you DSA. So you'll see that a lot of these companies are going to be asking data structures and algorithms in their interviews. So if you want to learn more about this course, there is going to be a poll in the chat. So you can click on yes, and someone from the team will reach out to you. You can also ask for one-on-one career advice. So if you have questions like with your background, should you do data science? What are the career opportunities, etc. So you can click on yes, and you can get personalized career counseling from one of the members from the Scaler team. Okay. If you need more information about the course, you can also go to scaler.com. Over there, you'll see the data science page, and you can fill out the form there as well. And again, someone from the team will reach out, and then you can discuss your situation, your career goals, your past experience. So if you have questions like, I don't have coding background, I don't have maths background, can I do data science, can I do machine learning? So you can ask these people. You can ask the counselors, career counselors. Okay, so thanks everyone. That's all I wanted to discuss with you. This was a gap that we saw in a lot of online courses and even in university degree programs, that they teach you just the technical side, but not the business side. And that is what we are completely switching here. We will start with a business problem, we'll break it down, convert it into a machine learning problem, and then teach you all the technical stuff that's required to solve that problem. Okay, so handing back over to Mohit. Thank you for allowing me to take a few minutes from your presentation, and good luck.
Thanks, Mohit. Thanks for explaining the entire thing pretty aptly. So yeah, as Mohit said, we generally get hired to solve business problem. So yeah, as well as technical, we need business domain knowledge also. And we at Scaler try to solve that. Yeah, let's coming back on the same note that we have looked at all the technical details, how basically regression is, and basically it's just fitting a line to all the data points, right? And we try to minimize basically the error to find the best line, right? I know there have been some doubts and all that. Let's try to look at it from a more actual real life linear relation, right? Now, I'm not talking about actual some kind of industry business problem and all that, right? There are a lot of things in our day-to-day life which follows kind of linear relation, right? One of the very common, one of the things which you keep on looking at, weather, right? And for the weather, one thing is Celsius and Fahrenheit relationship. Now, we generally say, like I've reached 104 degrees, the maximum fever, my fever is 101 degree. Someone says, okay, 98 is pretty okay. But we generally say, okay, the normal weather is 37 degrees, right? We keep on interchanging these relation, right? Celsius and Fahrenheit, right? The idea was basically the Celsius and Fahrenheit relationship, right? We keep on talking about fevers in 98 degree, 99 degree keep on terms, and we generally say normal weather is 37 degree. When it's too wintry, right? It's -1 degree, 1 degree, right? There's always a kind of, how would I say, interchangeable relationship. So there's always some kind of like relationship change, right? Can you guys help me with the equation? Can you just quickly Google it and can you help me with what's the equation for Celsius Fahrenheit conversion? Would really appreciate that. Okay, we have some equations and all that. Waiting for some from you, some more, basically. I think we have a common one here, right? That basically, like Fahrenheit temperature is something around 9/5 into C plus 32, right? Now, if you see something, right, there's very one common thing which we just talked about throughout the entire session, right? Don't you think this looks something like this? Y equal to A X plus B, right? We have Fahrenheit, which is equal to F. We have A, which is 9/5, which is the slope of the line. We have Celsius with another variable for us, which is X, and 32 as the B, which is the intercept, right? So even in real life, right, things which we talk about in labs, right, a lot of things follow linear relation, right? Now, let's try to actually look at and derive this equation from data point of view, right? We have talked about the entire maths and how we look at the like line, how we rotate it, right? But let's see its application, right? Without that, it's not really fun, right? You don't get the feel of it, right? So yeah, let's start looking at it. Let me change my screen to show you the actual code and how we done it and like how we can derive that. I hope you can see my code. Notebook share here. So yeah, let's get started on this part, right? We are importing some libraries to do all of our stuff, right? So yeah, now I have basically two data sets. Let me go into the actual codes in here. Yeah, we have basically two data sets, right? One is training where I have like basically collected all these Celsius and Fahrenheit numbers. I know these seem like very, very big numbers, doesn't really happen in the actual life, but to get something, right, you need a lot of actual data, right? So we have collected like basically from like created a data set for that, right? Then we have a testing data set, right? Basically where we don't have any Fahrenheit value because we want to predict it. We know that there's a linear relationship, right? So basically, a linear regression can actually predict that, right? That's what we're trying to do. So, okay, we have a training data set where we have actual value of Fahrenheit available, which is the actual value from our like actual equation, right? Then we have the testing file, right, where we don't have any variable, right? But we know the actual equation, which is Celsius into 9 by 5 plus 32. Let's try to replace with that. And we have the actual values now for like 259. This is 235. And again, I know these are very, very random numbers you don't really see in a real life, but believe me, it's more for like actually deriving this equation, right? Because as I said, right, when you have very, very small data points, right, you can do it humanly from human intuition point of view. When you go to scale, right, you need a lot of data. You have a lot of data points. Thus, you can use these algorithms. And one of the reverse things to say also, right, these algorithms actually need a lot of data to get up to that. So there's these random values which you never see in the actual real life, right? Now, as I said, right, we have to have the like linear regression to predict it, right? Basically, now have written training the simple linear regression, right? By training, what we mean is basically to find that best line. We have been talking about the best line fit, right? How to get the best line, what rotation, what sum of squared residuals. We need to like, take derivative of it to find the A and B value, right? Now, we did all of those derivatives and all that I show you, right? But in actual life, these simple things you don't need to, right? Because there's a lot of things you can't do it on pen and paper. You don't really have time. You have to solve a lot of business problems, right? So you let computer handle it, right? There are brilliant programmers like who have already solved this for us, right? So we basically like train our model and we have a linear regression model trained, right? And we basically we have test it, right? We try to predict it for our basically the second set where we calculated from the formula, right? So I basically predict it. Now, basically we have to do check what's the prediction, right? Now these are all like actual terms and all that other terms which we can later talk about, but let's take the actual feel of it, right? Let's take the actual how is it going and all that, right? And instead of showing you these weird things, let me show you the actual data set, what's happening. So what we did was we took the predictions and all that and put it into a basically table, right? Now this is Celsius, this is the Fahrenheit which you calculated from the formula, and this is the predicted Fahrenheit, right? Now, damn, it seems exact, right? Mohit, did you do something wrong? Did you actually just copied it, right, from the code point of view, right? Are you making fool out of us? Believe me, I'm not. I'm not really. I'll show you why I'm not, right? And like proof of it, right? If I just took a difference of it, right? Fahrenheit and predicted Fahrenheit, right? I took the difference and created a new column for our table, right? If you see these, right, we have some kind of difference values. When we go into further decimal points, right, we have some kind of prediction which is now it seems like okay, these are big numbers, but if you see, right, this is E minus 12, E minus 12. These are all mathematical notation to say that we have 10 raised to our minus 12 of a difference, right? So these are very, very small differences. So if I like see that is there a point, right, where we have actually difference more than one? None. Is there a point where the difference is less than minus one? None, right? If I have to actually visualize this particular data, right, actually visualize what's really happening, right, this is how we see that. We see the blue line, which was the actual data, right, because we have a linear relation between these two particular variables, right? This red line is actually the what we predicted, right? Now, but you are trying to like basically get the equation, right? So let's get the equation. right? Coefficient is basically the slope for us, right? Which is 1.8. If you divide 9 by 5, it's exactly 1.8, right? Our intercept, right, is 30.99999. See, this is the reason, like same thing, right? It tries to predict it to the best possible fit. Even with the exact value, we already know that the equation is already linear, right? It still try to get. If I would have added more data, might have it would be 32. At the end, we are getting this equation, right? Fahrenheit equal to 1.8 into Celsius plus 31.99, which is almost equivalent to Fahrenheit equal to 9 by 5 into Celsius plus 32. So basically, the idea of linear relationship, right? We have a lot of things in real life which actually can be denoted or can be represented by using linear relation, right? One is you already know it, but all these things which all these scientists and researchers have done, right? You can do it using data. In the past few years back from 2000, right? We didn't really have that kind of computation power for computer that we could have done this easily, right? I just like run the code in like few minutes, right? Now we have. That's why we talk about okay, the data is the new era, or this is the data age, right? You can get all these things, and all this thing like getting the equation derivative, right? Simple line of code, it's nothing fancy, right? It's at the end, it's a basic, very basic maths, as I explained, right? It's simple high school maths. You kind of like try to fit the line. For fitting the line, you calculate the error. For error, you basically you want the least error, right? Thus you take derivative to find it. I've also explained like you can do simple equal to 0 to get the slope equal to 0 value, or you can also do simple gradient descent, which is a further kind of a advanced concept, which I think is not in the scope of today. But the idea is to make you feel like this is not really overwhelming, right? Predictive analytics, which you do in a day-to-day life, when you do at scale, generally maths come in, but at the end of the day, right, it's simple high school maths which you did in back in school, right? Now, I know, even after like getting this equation, right, the question comes in that, hey, we have industry problems. We have heard about the housing pricing data set. There is things like, okay, we need to do EDA and all of that part. And there has to be missing value, out like kind of outlier treatment and codings and all that. Why we are not talking about that, all these kind of things, right? Now, let me just show you, come back to the slide again, a slide, so that I can talk about a few minor things. So, yeah, we just saw that okay, the actual real life relationship Celsius Fahrenheit, we can derive that if we have the data, right? It's the same thing, right? But as we talked about, right, the real industry life example that we have all those things, right? So let's talk about a few things, right? How outliers and missing data affect our best case, right? Best fit. Now this is the actual line, right? We have all seen this is the best line we got, this is the data set and all that, right? Let's introduce something like outlier, right? We kind of introduce a new point, right? Which is something like way far. If someone is not really aware with the term outlier, outlier is something which is not normal, which is something out of the normal range. Generally, we say as outlier, right? The red dot is something which was not really normal, right? In the graph, seems like something out, right? But if we get that normal, like something out of the normal range, right? Outlier. Do you think our best fit will remain same? No. To reduce that sum of square residuals, right? The line will change to become this, right? Now, do you think the actual value which we wanted to find for all those other variables or all the other data points will be the same? No, our predictions will be not as same as that, right? Now it's not as good as it will be earlier, right? Thus, removing points like this, right, outliers, it's very necessary. Think of a point where some of these get missing, right? Let's suppose this got removed, this got removed, this got removed, this got removed. Do you think our like prediction will be the same? No, it won't be, right? Because again, that it will try to go for the best possible line, right? That will kind of go for like the least error, right? And thus, again, this will get removed, right? Thus, things like outlier removal or missing point and all these, right, are very important from a point of how algorithm works, right? Every algorithm has its same kind of weakness, right? For this particularly, you can't really have outlier or missing values, right? Now, there's one thing that someone asked in the middle, right? If we have two particular data sets, we can take just two data sets and just try to fit a line, right? Let's take example of that also. Now, let's suppose I have some kind of this kind of data set where I just took two particular variables, right? Any kind of two random variables, right? And plotted, right? Do you think our line is the best fit for this? Do you think it's the best line? Do you think if I go and reduce the error, am I still going with that? I don't think we are, right? Do you think this is the right line for that? Right? This seems very, very better fit, right, than a simple line, right? The reason I'm talking about this, right, because each and everything doesn't need to be a linear, right? In an actual life or in actual industry problems, right, the relationship can be very different, right? But the basic question which someone asked, right, can you take a two different kind of any variable and fit a line to it? You should take two different variables to understand the relation, right? That's how we talk about industry, right? Let's say that we have said that, okay, what's the average order value of a real and number of products someone ordered, right? You need that kind of relationship to understand. If someone orders three particularly, basically, how would I say, three items, right? Then you would have some kind of like 500 rupees. If someone orders 500 five items, you will get something average order value of 700 rupees. A business needs to understand this, right? So that we can push our targets, right? If you remember, right, Swiggy has this example of basically that if you order something more than 300 rupees, right, your delivery fees will not be there. How do you think these 300 rupees get kind of there, right? How do you think this 300 get derived, right? We understand kind of thing, okay, you like a general kind of customer, right, orders around 200, 220 when he orders two particular items, right? Now if I have to push him, if I have to push him to spend further, right, I have to give some kind of incentive. That's why we give incentive, like, okay, if the average customer spends 220, we'll keep it 300 so that we'll push him to add one more item, right? Now at the end of the day, business like Swiggy is getting more, right? Even if you feel like, okay, you have saved some kind of money, right, we also get extra money. That's the win-win situation. Why these understanding these relationship between variables is very important. So yes, you can take any two variables and fit a relation to it. It might not be the linear always, right? It can be something like this is basically a something like a quadratic function, right? Instead of y equal to mx plus c, right? It is something equal to y equal to ax square plus bx plus c. But at the end of the day, again, it's a simple maths which we learned in back in 8th and 9th, right? And this is something called polynomial regression, right? Now, to learn more about this, keep tuning to further class sessions. And that's all for today from my side. Go ahead if you have any questions. I'm here to answer all those questions and all that. And also, uh, Prakash and other team members will put down some kind of polls. I would really appreciate if you can answer them. So, Digjoy has asked that in terms of trajectory, do you recommend descriptive to diagnostic to prescriptive to predictive in terms of learning? Yes, exactly. Any business, right, first needs to understand what's happening right now, then to find the solution. Why is it happening? To find the solution and to find then what will happen in the future, right? If the business haven't understand what's happening right now, how to get the solution and the recommendation for it, right? To understand the future is not really useful, right? If the business is not settled right now. So yeah, it's the best way to learn data science here. I guess there was a question which I missed. How do we relate this A and B with the variable height and weight? A and B is basically a line equation. Is A is basically slope, which is y equal to mx plus c, right? My bad if my like habit of using A and B instead of m plus c, but A is basically slope, B is basically our how would I basically intercept, right? Whereas y and x is basically the weight and the height, not A and B. I hope that answers if I hadn't earlier. So, Karthik just asked on the chat basically which data visualization tool is better. I personally use Tableau a lot, but I see that like Power BI is also a brilliant tool with the recent, I would say, integration with the Jupyter Notebook. Both are pretty good. If you're going to learn, you can try one of that. Tableau do has this thing that it is a paid thing and you don't really get the free version. Power BI do have student and the learning things, so you can try that out. Is polynomial regression same as logistic regression? No, not at all. As I said, right, linear regression is just fitting a line. When we said polynomial, the degree basically changed for the equation, right? Earlier we were looking at mx plus c. Now we added a square, which is becoming a quadratic equation. There can be x cube also, which is a kind of further degree, right? And all that. And there can be x4 also, right? That's the general term polynomial used for. Whereas logistic regression is for classification, right? Instead of finding Celsius, like Fahrenheit from Celsius, if I have to say that, okay, I have some goods, is it heavy or not, right? or will it be raining or not, right? Logistic regression is used for that classification, that 1-0 kind of thing, or 1-0 -1. Can you suggest for domain business acumen knowledge? Yes. You basically, the idea is to understand like how the business works, right? As I said, right? Let me take an example also, right? Back when we had like back in Grofers, we were trying to understand why there is a lot of reschedules, right? We did basic classification to understand whether order will be rescheduled or not, right? But at the end, what we realize is the way we are capturing capacity in Grofers is wrong, right? How do we understand this? By going to the warehouse, right? Multiple visits to the warehouse, understand what data is getting collected, how is it getting collected, and all that, right? So that's how business acumen really helps, right? That's generally what we don't really think when we learn about the simple technical stuff. Technical stuff is very, very important because without that, you can't really solve the problem. But to actually solve the problem, right, with the technical stuff, you also need to understand the business acumen. Now, how can you generate the business acumen? Generally, believe me, like when I joined the job, also these things we learn on the job, right? Or like to kind of read all these articles which you get online, right? The idea which I just put out, right, for Swiggy one, right? It's a very open article. Just search about the problems or the tech blogs which a company like Swiggy, Zomato, Grofers, Gojek, all these product-based companies solve, right? They have brilliantly written blog people from some brilliant people, right? You'll get the idea of how they are looking at business from a technical point of view. Someone asked best tool for predictive analysis for material planning and supply chain, right? I just explained you a very basic algorithm, which is called linear regression, right? When it comes to supply chain, there's an entire field called operations research, right? Uh, Vast field, right? As like there's a huge kind of thing, right? When you open Snapchat, there's filters, or like in Instagram, that's entirely comes into basically computer vision stuff. There's robotics going on to that comes into you try to understand things from text, right? The Amazon tries to show you those tags out of your review. That's come under NLP. Similarly, there's a very specific field called operations research for supply chain. I think when you start from the basic, you will suddenly go into there, and that's the best for material planning, I would say. What if there are more than one independent variable in linear regression? So as I said, right, we were looking at simple linear regression. And when we go into multiple linear regression, the idea is the same, right? Instead of using like line, once you have increased the basically the dimension of things, right? Right now we looked at only the 2D, right? The graph, y and x, but then we will have x, y, z. Then we can have x, y, z, p, q, r, right? Multiple variables, right? We can grow from a line to plane and then hyperplanes, which human can't imagine, right? Again, validating the idea, right? Human intuition can go till a point, right? But to understand further, right, you need to have the maths, right? Because computers doesn't really need to understand and imagine those dimensions, right? It will just go with the equation. So yeah, for more than one independent variable, there is something called multiple linear regression that goes into hyperplane understanding. Same concept, same derivatives and all that, right? Just for different variables multiple times, right? Again, as I show in the code, right? It's the same line as that, nothing more. Computer does it for you, right? But it's good to know, not just good to know, it must to know that how it is working, because in a lot of problem times when it is not fitting, right, you need to figure out what's wrong with the data, why it is not fitting, how can we fit better. How do we differentiate a use case from linear to quadratic to polynomial function, right? Basically, how do we differentiate as in the real industry problems and all that, right? That we first, as I said, right, you take any two data sets and understand their relationship between that, right? Even after that, there can be combination of variables which have a different relation with different combination of variables, right? That generally comes under there are different tests, and also hit and trial is a famous method, right? You have to hit and try, right? General problems is not that easy as I showed you to run the code, right? A good part of my job is just to keep on trying and exploring, right? Even if the idea is just to get a value out, right? You have to keep on understanding what this variable means, how it is related to another variable. Can it change if I change this variable? All of this to understand, keep on iterating, right? Keep on iterating. So even if I have to do a Celsius to Fahrenheit, right? If it would have been my job project, right? I would have spent 80% of my time to understand basically the relation between two to three variables, then predicting, right? That's the essence of data science when you come into industry, not running the models, but to understand the data and the business concepts. This is a very common question when someone asks. Ravi Rao has asked, can I be able to do data science as I don't have good maths or statistics or programming background? Uh, Yes, all of them are required. But believe me, one thing good about this entire hype about data science, right, is that you have endless material available, right? There are companies like Skill Academy and other ones, right, which have these very, very good courses out there. You have to be patient and willing to learn, right? It's nothing tough. That's what I'm trying to say, right? And you can just give it a hand, give it a try on your own also. If you think you're not liking the maths, then yes, this field might not be right for you. But if you think, right, like when I started this entire session, I talked about descriptive, diagnostic, and prescriptive analytics, right? The entire data profession is just not data science. There are like professions like data analyst, business intelligence engineers, right? Analytics manager and all that, whose not job is to not predict things, right? Whose job is to basically understand what's happening right now and how to solve that, right? So you don't really need good math and statistics for each and every data profession. There are professions which value your business acumen and logical aptitude more than programming and statistics, right? But yes, if you are like very, very like bend on to go into data science, you need maths. So Shankar have asked when linear regression is not recommended. You try it. So basically, the very idea of how to solve the problem, right? You start with a very, very basic algorithm, right? Like linear regression, right? When you talk in the industry, we talk about what's the baseline model, right? You can't just go and say, okay, I have accuracy of 90%, 95%, and all that, right? You have to compare it with something. Believe me, in industry, you really don't get those numbers of 90% and all that. A lot of problems get solved at like 75 or 76%. That's the best we get, right? But how we can say that, okay, 76%, right, is the best one, right? You start with the very basic one. Linear regression might just give you 20%, right? That's the baseline model. You improve it further by using some kind of other regression or classification. And slowly, right? So when linear regression is not recommended, nothing like that, right? You have to try the baseline. It's a good baseline model to have, right? But there are a lot of time when it will not fit, because linear regression is again a line, right? A lot of real life things are not really a simple line, even not a polynomial regression like also, right? Because it's just a smooth graph. There can be relation with zigzag, 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 right? There are different techniques for that. But you still have to start with somewhere, right? You have to try it. You have to understand why it is not working. And linear regression is very, very good at understanding relations between variables, if not at solving the entire problem. I hope, Shankar, that answers your question. What if we are in ninth and what maths do we have to learn? Man, if like it's the all maths, right? Our school curriculum is really well designed for maths. There is a reason why generally all the net hype Indians are good in maths and all that. There's a reason for that, right? We have a really good curriculum. Just learn all the basic maths. It's very good for. If you're good at that, there's a lot of line which is like pretty easy to understand. Sagar has this question. I am from IT background. Which DA domain should go? I don't understand the question by domain, but doesn't matter again. If you want to go for DS, yes, you have to like take in like maths and statistics. DA is more like your logical aptical thinking. That if I have to ask you a question, we have a service center and we have like waiting time in there, right? And basically, how would you solve that? Right? These kind of questions business have to solve on day-to-day basis. Your day-to-day normal logical thinking, right? If that is your strong point, go for DA. If you think you are good and you want to be like into the algorithm and you want to write things or you have to do it to maths, you're really fascinated by that, DS is the place to go. But there is nothing recommended on that side. It's your liking. A good amount of jobs available in analyst data science roles in month of Feb and March. Which month we get highest openings? Sandeep, I'm not sure I can answer that. But yeah, right now it's a booming industry, so roles are always open. Keep on the lookout. Karthik A has asked a question. What is the use of terms like TensorFlow, Keras? Okay. So I don't think you guys got a point where I was like running a code, but for like running linear regression, I was using a package or Python library called sklearn or something called scikit-learn, right? People who are not really aware with Python or Python package, Python is a very basic language. People have built things on that, right? If I have to do the entire maths, right, of the linear regression, I could write the code for it, right? But there are people who have done it, and you can just say run linear regression, as simple as that, right? That's the role of a package, right? Scikit-learn is a package which have linear regression, right? TensorFlow, Keras, right, are packages. So TensorFlow is a different library which is made by Google. Keras is something which have made easy to access TensorFlow for normal developers or data scientists like us, right? At the end of the day, this is just for another kind of algorithms which you generally talk under the umbrella of deep learning, right? That TensorFlow Keras library has. Nothing fancy, nothing like hi-fi. These are just different algorithms, set of algorithms, and different library package which has it. If wanted to predict monthly retail store sales, can we use regression? Yes, we should use regression for that. It's a continuous variable and we use regression. Which ML techniques best to use? Again, as I said, right, you start with the very baseline as linear regression I just explained today. There are multiple algorithms like random forest, decision trees, XGBoost, and all those kind of things. Depends, you have to try, you have to understand why that algorithm works. Jay Kumar Ji has mentioned, can you please mention the software name for supply chain? Again, it's not a software name which I was mentioning. It's an entire field of study called operations research, which focuses mainly on supply chain planning. Supply chain planning is heart of a lot of business, right? Amazon, Flipkart, Swiggy, Zomato, Grofers, all of these business would not be there if they would not have done supply chain planning, right? It's a core of a business, right? And there's an entire field of study for that. Operations research is there, right? And there are multiple softwares for that, but I'm not really specialized in that. So I'm not really would be able to answer that rightly, but there's an entire field for that, operations research, if that helps. What's the difference between ML and DL? Uh, ML is all those maths algorithm I'm just explaining you, right? This is the start of the ML. DL is the study of human brain, how neurons really work, right? Because at the end of the day, what we are trying to imitate is basically how human brains work, right? Because when we are a baby, we just start from scratch, right? We also learn to walk, to understand, to learn more things, right? DL is a field of understanding that, right? It's a more, I would say, complex field as compared to basic ML. That's why we generally, in any curriculum, right, any kind of understanding, you first learn ML, right? A lot of problems get solved by that. A lot of, believe me. And then you go into DL. And there are a lot of problems you can't solve by ML, like images problem, or like text. The latest state of the art, the research in the last 5 years on text data is on the deep learning side. DS is greater than ML is greater than DA is the right order. I'm not sure what's the like thought process behind the question, I would say, but there is no greater than or less than kind of order between them. So data science includes ML as a tool. Machine learning is a tool for data science, right? But fields DS and D is entirely opposite. These are two, not exactly two exclusive roles, but as I said, right, data analyst as a person thinks about what's happening right now, what's the reason behind it, and what solution they can recommend. A DS thinks of the future already right now, right? What is, if I can predict things already? What's going to be the sales in the next month, right? These kind of things, right? There's no greater than lower than kind of order for that. It's on the interest and different application of both these professions. ML is a tool for a data scientist. Rachna, ANOVA is included under regression. Which regression? ANOVA is not really covered under any regression, but yes, the idea of regression, right? The regression means, the word regression means to find the mean, right? Regress mean mean. Even when we did all the data points, right? I did basically try to find the mean of all those things by looking at the error, right? So regression, although at the end trying to find the means. It's just that not looking at the entire mean, we are looking at bucketed mean, right? Of this particular variable, this is the mean, this is the mean, this is the mean, right? ANOVA is something else. It doesn't really come under the regression bucket. But yes, it's a technique to understand relation between two variables. Regression also does that. So the idea behind both the technique is same, that we try to understand the relation between two variables, but output or like the way we use its application is not. Someone asked, Umesh have asked that, can you please explain a bit about autocorrelation? Not really the part of today's session. Autocorrelation is more on the side of when you talk about, uh, how would I say, general like exploratory data analysis or even in time series data. But yeah, the idea of correlation, like before even autocorrelation, we should talk about correlation, which is a different entirely thing. Again, someone said, right, ANOVA, regression, and even correlation. The idea is to understand the relation between two variables, right? Different way to different output. Regression, you want to find the actual value. Correlation tells, is it positive or not? If I increase temperature, will something like, how would I say, increase of sale of basically ACs will increase or not, right? It's a positive correlation. If it's summer, ACs will sell more. If it's like lower, sweaters will sell more, right? It's just positive to negative. Regression tells you how much sweaters will sell more in winters, how much sweaters will sell in, how much ACs will sell in summer if the temperature is high. Two different things, but at the end, it's understanding the relation between two variables. Tushar asks how you can take care of multiple variables come in picture in real life scenarios. Again, from a code point of view, as I showed, it's a very simple, but from understanding point of view, right? We talked about 2D right today when we looked at just like slide 2D. When you look into multiple variables, the idea is to understand from a higher dimension, right? Our real world is 3D, so basically three variables, right? Let's suppose there are 10 variables, right? You can't imagine it. At the end of the day, it's maths, right? Now, instead of ymx plus c, you have ax plus b, x plus c, something, something. You have multiple variables there, right? Kind of keep on going x1, x2, x3, x4, and all that, right? At the end of the day, you're doing the same, right? You're finding the error. You're taking both all the variables. You're finding the derivative value out of that. You have multiplication. You solve for that, right? That's how you get like ax1 plus bx2 plus cx3, all these values of a, b, c. At the end of the day, it's simple maths when you look from maths point of view. But when you look from intuition point of view, you are looking at hyperplane geometry, right? Which is something very overwhelming. You have pharma cases. Akhil have asked question, do you have pharma cases? And yes, we do. Just take about a think of a sales point of view. Pharma business generally take a look at the sales point of view a lot. How much sales gonna be there because they have to produce that many medicines, right? Think about our like vaccine manufacturing, right? Which we like in entire world went through in the last 2 years, right? So regression comes a lot and help in there, right? Not exactly linear regression, maybe, but like understanding like how much sales gonna be there, right? In the next 1 month. It both comes under time series as well as regression, right? Depends on how you treat the problem. But yeah, that's a pharma use case. Swastik GH have asked, do you think data analysis and data visualization have any role in the industry? Please, yes, there is. There are a lot of vacancies. And again, I'm repeating it to the nth time right now that both are very good roles. It depends on your liking. Puneet, I worked for Walgreens in US in their basically to understand which clinical trials they have to run and all that. You worked through a like service company before that. So yeah, I think that's what exactly asked. What kind of like specific thing you're looking for? Do let me know. Someone asked only historical data play a role in predicting the outcome. What is the max probability of correctness of such outcomes? Again, as I just showed you, right? Like if think of a way that scientists would not have created these two variables, Celsius and Fahrenheit, right? Let's suppose these two have things, right? And you have that much data passed, right? The way you can determine that relation is from the past itself, right? You have to collect a lot of data. The reason we collect a lot of data, right? You open an app, how much time you spent on a particular like page, what you clicked, what you didn't click, right? All of this data, right? What is the max probability? It can be as much as 99.99 also, right? And believe me, any data scientist would be very, very happy if it can be, right? That's a theoretical limit. It can be there, right? But generally, in a normal day-to-day industry cases, we have around like 70 to 80, 85 also some cases, right? Believe me, for Walgreens, when I was forecasting in a case of hurricane, we also got kind of, there's another metric called MAPE, which usually got around 93%. So there is no maximum probability of correctness, right? There is something called quantile regressor, again, way more advanced concept than today's scope of class. But you can also find that what is the window in the prediction. If you don't want to tell the exact, let's suppose, output, right? Like something like 96 is the weight, or like as you said, right, 75 is the weight. If you don't want to talk about the exact 75, right, you can talk about the weight will be between 73 to 77, right? That's what Swiggy does or Zomato does when they're delivering your order, right? They tell you about we will deliver it in our 20 to 25 minutes at the start. And slowly they come from 20 to 25 into exact 23 or 22. That's how they come up with. His main challenge in ML is data preparation, Karthik. Yes, yes. Believe me, 80%, 85% of my job is preparing data, then trying out algorithms. Gancham Abrol has asked that how to use it in agriculture. I would really like to answer this question because again, India is a very agriculture focused country, right? There are companies like Nurture Farm, just like search it, who works mainly on these kind of things. There are brilliant starters out there who are working on India specific problem like agriculture, right? Which like how much of the like we need the fertilizer for a particular land, right? They work on the satellite image data kind of things, right? So do search about them. What kind of upskilling would you recommend to someone who's currently working as a data analyst and looking to switch to a data science role? The reason I have like read it aloud is because I used to have this question a few years back. I started my career as a data analyst mainly, uh, kind of back in Grofers, and I switched to data science. Again, as I told, right? For me, I had the business knowledge already because I was already working in the particular field for a lot of time. For me, upskilling was basically just the technical part, right? For a normal person, technical again is a very important part, but business again is the same, right? One thing again, I'm repeating, right? One thing which Mudit told you came from our feedback from us, like people like us, right? The techniques, yes, and that path has been followed from last 5 years now, right? A lot of data science, like kind of courses or lectures, or I would say resource focus on techniques, and that's very very important. But you can't really make sense of these techniques till you don't have the business domain, right? So I would say if you want to upskill, if you're working as a data analyst, I believe you already have the pulse check on the business side. Focus on the technical. Gancham have asked, thanks. What about food processing? I want to implement it for the food product storage prediction. Again, product has a lot of things like expiry dates, how much shelf life it is there, and all that, right? So more than predicting, you first need to calculate, like I would say, log the data, have that real time check, how much like it's getting expired, you need to sell it, that there is a shelf life, how much product do you need is depending on the sales, you need to find the sales, how much that particular product will sell for, how fast it will sell, what will be the, and all that, right? So it's not just one problem, it's a very like vast problem of product storage prediction. Believe me, a lot of companies are still struggling with that. Shankar have asked, I guess this is kind of last question for me. And thanks for there. I'll ask one last kind of whether model deployment also taken care by data scientists or separate team. Again, depends. There are like companies where they have specific teams, which is called data science platform or ML ops team. And that generally when the entire company's data ecosystem is very much matured, right? Think about Facebook, Google, Microsoft, and all that, right? Because their scale is so large, right? Recent news was Microsoft has 1.4 billion Windows devices, right? When you go in those kind of things, right, you need a very brilliant scale of things, right? And you can't imagine a person to have each and every skill, right? A data scientist can't know the business domain as well as the uh, stats, maths, and as well as the part, right? You have to for some extent, but after a while, you can't be a specialist in each and everything, right? So they have specific teams, but in my last company, Growfers, we are a startup, right? And kind of we don't really have that scale. So we had to take care of data basically deployment ourselves, but our scale was not that high that we need specialized technologies. So yes, it depends on company to company, but you need to have at least some amount of 20-30% of the deployment knowledge also. Things like Airflow DAGs and Kafka and all those things, kind of things. I'm really thankful for all of you who joined here. Looking forward to have some other time connect. Thank you.